Hello. So I wanted to show you how to use some StatsMedic tools for the Module 3 test, which by the way you'll be able to use, and the link to that is in the directions there. Now the applets that you can use are down at the bottom here when you get to the StatsMedic page under Traditional Inference. And of course I'm going to be showing you how to use those with problems from the practice test, so as to not give away problems on the actual test. So if I want to do a problem like number 1, where essentially I'm making a confidence interval of this transistor problem, some things it can do is it can make the confidence interval for me. Then I'd have to do some other stuff from there. So let's see, I just need to click on one sample z interval for a proportion. Since that problem was talking about confidence intervals of a proportion. And so I can go and give it a variable name. So this one was transistors. And that they were good if they were within specifications, they were bad if they were not within specifications. And so in that problem, it's saying 148 were within specifications out of the 160. So then I have to type in those frequencies. It doesn't give me an option to put in the total. But since I know the total is 160, I just have to figure out real quick that the leftover transistors that are not within specifications, there's 12 of them. So then I go ahead and click Begin Analysis. And it shows me some of that stuff there, which I don't really need any of that there. What I need here is now where I can make the confidence interval for me. And see, this problem was talking about making a 95% confidence interval. Notice that's the percentage selected here already. And under Good, since that's the category I'm looking at, just click Perform Inference. Then my upper and lower bounds of that confidence interval are 88.4% to 96.6%, which are pretty darn close, if not spot on. Yep, spot on with those in the key there. So that tool can give you the confidence intervals, but notice it does not give you the margin of error. And the other tool will be like that also. But what you can do to find your margin of error is use an idea like this one in number 3 here, where you just take the upper limit of the confidence interval, subtract the lower limit of the confidence interval, then divide that difference by 2. That'll give you your margin of error. So that's something you could do here as well, is just take 0.996, subtract 0.884, get that difference, divide it by 2, and you should still get 0.048 for that margin of error. So let's see, then I'll show you another applet you can use for a confidence interval problem like that of number 2. Where you're making a confidence interval based on means. I'm just going to go back there, and now this time I'm just going to do a one sample t interval for a mean, since that one was from a sample with a sample standard deviation. And I'm going to want to make sure I'm typing in the mean and standard deviation input option there. So let's see, that problem was talking about IQ scores, and it's going to be a 90% confidence interval. Let's just go and do IQ, just something short. And let's see, the mean of that one was the mean IQ of 113. The standard deviation was 22 from that sample. And the sample size was 61. So that's all the information I need. 113 for the mean. Then, let's see, 7. Was I forgetting that already? Nope, it is 22 for that standard deviation. And then the sample size, that was 61. That's all I need to type in, and then begin analysis. And when notice it's giving me the option to do an interval at 95%, so I'm just going to change that to 90%. Perform inference, and it's telling me that my lower bound should be 108.294 to 117.706 for the upper bound. And notice that is still correct with this interval that I have here, just different decimal places. So it gave me the interval, and all I have to do to find that margin of error, again, is just take upper bound, subtract the lower bound, divide it by 2, and I would still be getting about 4.71 in that case. Alright, so those are some applets you can use for confidence intervals. Now, there isn't one for a confidence interval of standard deviation. That one you'll have to do with the tables and such. Now there's also some applets there you can use for hypothesis tests, still in that same section under traditional inference. So let's see. Want to do something like this one where it's a hypothesis test for proportions. I'll go ahead and do one sample z test for a proportion. Click on that. Setup here looks pretty similar. And let's see, this problem was the soda problem. And so 98 said they preferred the cactus cooler out of the total 175. I'll just go into the total of soda. For those that prefer the cactus cooler, then there were 98 of them. And then so for those that preferred squirt, you see out of the 175, there were let's see, how many left out of 175 there? There should be 77 left. Analysis, again, don't really need this stuff here. What I need is down here under where I can actually do the hypothesis test. Notice the category I'm looking at is cactus, so the one I want. I can change this here to whichever option I'm looking at. In this case, since it was a two-tailed test, I'm looking at does not equal. And then for hypothesized percent, I'm going to type it in as a whole number, so 50, since that's a percentage I was looking at, and that's the way that StatsMedic will want you to type it in. When perform the inference, I should be getting a p-value of 0.112, and that test statistic of 1.587, which it looks like. So the p-value is 0.1118 when doing it the other way, which is pretty darn close to this one here, and 1.587 for the test statistic there, which is very close to this version as well. So both of those answers will be close enough using either way, using the applet or using the old-fashioned way. Okay, and then there's one more applet where you can use it for a hypothesis test for means, but there isn't one for a hypothesis test for standard deviations as well. So I'm going to use in that same category one sample t-test for a mean. And again, I want my input option to be mean standard deviation. And let's see, that problem on the practice test was talking about a keto diet. And let's see, there were 21 people. There's a mean cholesterol of 188, standard deviation of 7.03. So remember all those this time. Keto, 188, 7.03, and 22, 21. And again, begin analysis, and it's giving me some options for hypothesis test. This is all I care about here. And this one was a greater than option, greater than 185. So that's the option that I want, is mu is greater than. Just go and type in that mean, 185. And it gives me my test statistic of 1.956 and the p-value of 0.032, which are spot on, if not just very close to my answers there. So either method will work, because both methods will give you answers that are close enough, and for hypothesis tests, they'll lead to the same conclusions of rejecting or failing to reject null hypotheses. All right, and that's how you can use some of these applets for the test.